Hey guys, today we are going to talk about vectors, and this is still in the same unit. This is just going to be lesson 4 in your book if you follow along in your book. So vectors a lot of times are used in physics, and it's just like it has a lot to do with like force and acceleration, momentum, things like that. So it's notated in bold letters, but like when we're like doing our homework, we can't really bold our letters. So like a lot of people just put like the arrow above it, and that is representative of a vector. Okay, so a vector, I'm just kind of jumping around here. A vector has both a direction and a magnitude. And a lot of this is going to feel familiar to you. A lot of it is going to be new as well. So I want to kind of start off with the basics of a vector. So let's pretend like we have this vector right here. This length is called the magnitude. And this is the tail. So that's like the initial position. And this is a head for the terminal position. And also notice like it has a definite direction. So if I had like the same magnitude, but it was going like down this way, my vector would be different because of the direction is different. Okay, also something else, let's call this vector, I'm going to do this in a different color. Let's call this vector A, B. Okay, so if I were to label this vector, I would label it AB versus, and then if it went this way, it would be BA. So direction counts there. We'll talk more about that later. I just wanted to kind of hit that. Okay, so we're going to compare these two vectors. So I'm going to compare vector AB and BA. Okay, so I'm doing vector AB right now. Oops, I didn't put the arrow. Oh, goodness gracious. Okay, and this arrow, that is like representative of like a vector, not like array or line or anything like that. It's different. Okay, so if I put the arrow on this side, so I'm going to still call this AB the way I read it left to right. But when I talk about this, this is going to be, so this, the top one is AB, the bottom one is BA. Notice my arrow goes the same way, but I flip those letters. Okay, so the magnitude, remember, let's go back up here. The magnitude is that length. So notice that AB and BA have the same magnitude. Magnitude, the notation for that is kind of like an absolute value. So I'm going to write it like this. So the magnitude of AB is equal to the magnitude of BA, and let's count. That's 1, 2, 3, 4, 5. And it is 5. So magnitude, again, is the length. Okay, so let's go down to scalar. So if you had matrices, we've talked about scalar in like when you're dealing with matrices. But this is pretty much the same concept if you're familiar with that. So we only deal with the magnitude only here. So this deals with like speed of a car, distance, time. So this is a lot of like where your physics comes in here. And so the notation is just like a lowercase. So let's put this to work. I'm going to draw, I'm going to draw this vector right here. So notice it's like the diagonal of a square. And I'm going to call that W. Okay, well, if I make another vector that is 2W, it's going to be this and this diagonal. So that whole thing is 2W. Okay, so let's go the other direction. So if I'm going this direction, yeah, that's really little. If I'm going this direction, that's negative. So I have 1, 2, 3, let's just do 4. Okay, so this is the length of W, the magnitude of W times 4. This is going to be negative 4W. Okay, so we've talked about the basics, we've talked about scalars. These are all the different properties of vectors. So notice like this one, commutative property, that's nothing new. Associative property, nothing new. Scalar property, that's nothing new as well. And distributive property, nothing new. So if we have the length of KU is like this, hopefully all that makes sense. So we're gonna like put all that together here in a second. But just don't forget that this is like magnitude. So like the length or the magnitude of K is times the length of U. So K, the magnitude of KU is a magnitude of K times the magnitude of U. So just get used to that notation. But other than that, like it's nothing new. Okay, we're going to talk about 3 more things that you're going to come in contact with. The first thing is a resultant vector, and that is a vector sum. And so this is going to be like A plus B. So let's pretend that this is A and this is B. The resultant vector will be this, which is representative of A plus B. The 0 vector, we've kind of already had this. It's a vector and its opposite equals 0. So let me show you this. Come back up here. This is an example of a 0 vector because let's pretend like this is, we started here. Oh, goodness gracious. We started here and we went, what was it, 1, 2, 3, 4, 5 units this way. And then think about it like in common sense terms. You went 5 back. So like you're ending up in the same spot. So that's what that 0 vector really represents visually. So I'm going to say, we'll write it out like algebraically. So let's go back up here. If I had, so this was 5 and this was 5. So I have 5, but then this is going the opposite direction. So that's negative 5. So if I were to add those together, that would be 0. Okay, and the last thing is a unit vector. And this is just a vector with the magnitude of 1. So remember, magnitude means length. And it can be anything. So I'm just going to put 1 unit. One more thing I want to point out is the magnitude and the direction of the vector. So the magnitude equals this a squared plus b squared square root. So think about what you know about Pythagorean theorem. And this is all going to make sense in a second, but I just want to have this written down for you. This part right here I added in. So think about, we've had this before. When you have a slope of the line, so remember that would be the tangent of theta anytime you have the slope. So this part is nothing new. We're just going to kind of revisit that. So let's go on to an example. Okay, so we haven't really talked about this. This is the coordinate of the vector. So this is going to be representative of A and B. So let's go ahead and fall back on what you know. So we have negative 5, 1, 2, 3, 4, 5, and then 4, 1, 2, 3, 4. Okay, so our vector is going to go to that point there. And this is our angle measure. So really, this should all be very, very familiar to you. So let's talk about the magnitude of this, and then we can talk about the direction. So the direction, that's going to be your theta. The magnitude, we're going to go back up and put it into this formula. So let's go ahead and do that. So we have this u, and remember, that's what I'm talking about right there. Equals, and it's a squared, I'll just go ahead and write it. So I have 25, that's a squared, and then plus 16, that's b squared. Okay, so 25 plus 16, that is 41. So I have the magnitude of u is the square root of 41. Okay, now let's go to direction. So I'll do this in a different color. So let's go back up to this formula. I forgot I wrote that down. It's the same thing as what I said. So we need to figure out what theta is. So I know that the tangent of theta is b over a. So let's go back to what I talked about. So this is 4, this is -5. So we have b, which is 4 over -5. So then we're just going to do the tangent inverse of -4/5. And that is, remember, I'm going to go ahead and find the tangent inverse of 4/5. Make sure that you're in degree mode here. Okay, so the tangent inverse of 4/5, make sure, nope. Is 38.66. Okay, but that's in quadrant 1. And so in quadrant 2, I'm going to take 180 minus that, and I get 141.3 degrees. And so that is going to be my direction of my vector. Okay, and so for this last example in this video, we're just gonna kind of just go over what to do if you see something like this in a problem. So sketch an arrow representing a plane's trip u of 400 miles on a course of 300 degrees. Okay, so think bearings here. So this is really nothing new. So you have this, so you have your coordinate plane. Okay, so 300 degrees, let's see, let's call that right there. Okay, so this is 300 degrees, and this is our u. Okay, so our u means this is representative of 400 miles on a course of 300 degrees. So I'm going to say that. U means 400 miles on a course, oops, goodness gracious, it's really messed up, of 300 degrees. So when you're dealing with vectors, don't forget, like, you've got different pieces to it. So you're talking about like the magnitude and the direction there. Okay, so let's go on to B. So B says sketch for u, 4 times u, and tell what that trip represents. Okay, so I'm going to attempt to draw this again. I'm going to give myself some more space. Okay, so think about this. I'm going to go 4 times that. So we have, so there's 1, 2, 3, 4. Oh, that looks hideous. So this is 4u. And this is also on a direction of 300 degrees. So let's think about that in terms of the problem. So if we're going 4u, we're going 1,600 miles because we're going 400 miles 4 times. Oh my goodness, guys, I'm having some issues. I can't spell or write numbers today. Okay, so 1,600 miles on a course of 300 degrees. Okay, now let's go to C. So C is negative u. So think about this. If u is going this way, it's going to go